In this lecture, we'll discuss one very important formula from ITF, and that is a summation of two tan inverse functions, and that is tan inverse x and tan inverse y. This is very important and common formula in ITF. Students generally try to mug up or you can say remember this formula, okay? But still they don't know the proof of this formula. Okay, actually, students remember only the first part. See, this part generally students will remember. That is the first part, tan inverse x plus y by 1 minus xy. Okay, for xy less than 1. Okay, but if you are preparing for IIT, okay, then we should remember all the branches, okay, with their conditions and proofs. Okay, so let's discuss about the proof of this formula. So first of all, to prove this formula, here we have tan inverse x plus tan inverse y. Okay, so just try it here, tan inverse x plus tan inverse y. What we'll do here, we'll suppose this tan inverse x and tan inverse y something. Okay, let's take this as a. Let's suppose this as a and this as b. Okay, so clearly from here we can say this a and b obviously will lie between minus pi by 2 to plus pi by 2. That is the range of tan inverse function. Okay, so clearly a plus b will lie between minus pi to plus pi. Clear, no? Minus pi to plus pi, because this is from minus pi by 2 to plus pi by 2. This a and b also from same range. That's why a plus b will definitely lie between minus pi to plus pi. Okay, now also from here we can say if this tan inverse x equal to a, then this x equal to tan a. Yes, we can say x equal to tan a, and this y equal to tan b. Clear? Now also we can say for this x and y can be real number because the domain of tan inverse function is real number, no? Okay, now also we have to write the relation, okay, between this a and b here. Okay, I mean to say we have one formula, tan of a plus b. Do you know that formula? Tan of a plus b is tan a plus tan b by 1 minus tan a tan b. Okay, from that formula we can relate this a, b and xy. Okay, so just write the formula here. We know tan of a plus b is tan a plus tan b divide 1 minus of tan a into tan b. Okay, just replace this tan a by x and tan b by y. So we'll get x plus y divided by 1 minus of xy. Clear? Now what we'll do now, we'll apply tan inverse on both sides, okay, in this. So applying tan inverse on both sides. Okay, so we'll get here tan inverse tan a plus b equal to tan inverse of x plus y by 1 minus xy. Okay, but see, simply we can't write here a plus b. We know tan inverse of tan function is not simply x. Okay, that depends upon the graph, okay, and branches of that that value. Okay, on which branch this value will lie, that depends upon that one. Okay, so let's draw the graph of tan inverse tan function. Okay, then we'll discuss about this a plus b. Okay, because you know a plus b lies between minus pi to pi. See, we know this a plus b is definitely lie between minus pi to pi. We have found earlier. Okay, so this tan inverse tan x function is definitely not a plus b. Okay, we can't write a plus b simply here. Okay, so what we'll do, we'll draw one a graph, okay, of tan inverse of tan function. Then we'll discuss from there. Let's draw here only. See, tan inverse tan function graph will be like this. This you have to break. This is pi by 2. Okay, this is definitely pi by 2. You have to break at both the points. This is minus pi by 2. Here again, graph will start, and the line will be like this. Okay, like this. Okay, and so on. Again, the graph will start from here, like this, and so on. Correct. Okay, so this is pi by 2 here. This is minus pi by 2. Okay, again we have to draw one more branch because we have to see in minus pi to pi. So next branch will be like this. Okay, this is minus pi. This is again pi by 2 here. This is sorry, this is not pi. This is minus 3 pi by 2, minus of 3 pi by 2, and this is your minus pi. Okay, this is 0, this is pi by 2, this is pi, this is 3 pi by 2, and so on. Okay, now clearly this is the graph of y equal to tan inverse tan x function. Okay, from this graph it is clear that from minus pi to pi, the branches we have one this branch. Let me dark this branch, one this branch. One is we have this branch, okay, and one we have this branch here. Okay, we have three different branches between minus pi to pi. Okay, so can you guess the equation of that branches here? Yes, we can definitely say this is y equal to x. Okay, this is y equal to x branch. Okay, what would this branch? Y equal to x minus pi. Okay, what about this branch? This is y equal to x plus pi. Okay, so these branches we have here. Now, definitely, if tan inverse tan x, where x between minus pi to pi, that is not simply x. Okay, we have three different branches here. Between minus pi to pi by 2, we'll get x plus pi. Between minus pi by 2 to plus pi by 2, we'll definitely get x. And from pi by 2 to pi, we'll get the value x minus of pi. Okay, so we'll write separately here. So therefore, from here we can say it this as equation 1. Okay, we'll recall again this. So first of all, write this one, tan inverse of tan a plus b. Sorry, tan a plus b Okay, so tan inverse of tan a plus b will be, see this branch we have here, x plus pi, that is a plus b plus pi. Okay, and this is for which x? Minus pi to minus pi, sorry, minus pi to minus pi by 2. Okay, this is minus pi by 2. Okay, minus pi to minus pi by 2. So let me write here minus pi to minus pi by 2, where this a plus b lies between minus pi by 2 to minus pi. Clear? Okay. Oh, minus pi to minus pi by 2. Okay, now it's correct. Next we have next branch. This is y equal to x. So this is simply a plus b. Okay, and this is for which x value? Minus pi by 2 to plus pi by 2. So definitely this a plus b, if a plus b will lie between minus pi by 2 to plus pi by 2, then the value of this tan inverse of tan a plus b is a plus b simply. Okay, again clearly we can say this next branch is a plus b minus pi. Okay, and this is for which value of x? That is pi by 2 to pi. Okay, so this is pi by 2 to a plus b will lie between pi. Okay, we know we can't include any of the values here because see at minus pi by 2, the graph is opened here, no? At minus pi by 2, that is graph is not defined, the value is not there. So again at pi by 2 value is not there. Okay, again at minus pi, we already have minus pi and pi excluded. Okay, so we should not take here. Now we'll discuss about this these branches. Okay, we have to find the value of x and y. Okay, that we have to solve these inequalities here. Okay, now let's discuss all the inequalities one by one. Okay, now first of all, I'm taking this inequality here, minus pi to minus pi by 2. Okay, so clearly for minus pi to a plus b minus pi by 2. Okay, we'll solve this inequality. We'll find this inequality in the form of x and y. So minus pi and a plus b means what? Tan inverse x. We already supposed earlier, no? Tan inverse y. This is minus pi by 2. Okay. Now, what can you predict by seeing this inequality? Okay, definitely this whole inequality is what? Negative. Okay, between that is between minus pi to minus pi by 2. Okay, so definitely this is negative, no? So clearly this tan inverse x and tan inverse y should be negative. Okay, so from here we can say this tan inverse x and tan inverse y both should be negative. Okay, because see tan inverse x lies between, see tan inverse x lies between minus pi by 2 to pi by 2. Okay, again this tan inverse y should lie between minus pi by 2 to plus pi by 2. Okay, if this is greater than minus pi, okay, then definitely this both should be negative, no? How can we say? Because if you'll add these two inequalities separately here, tan inverse x and tan inverse y, that is the range of this tan inverse functions. So definitely this is between minus pi to pi. Okay, so for lowest range minus pi, okay, this both should be negative. Okay, and one thing you can say, see here minus pi by 2, no? If any one of the tan inverse and tan inverse y is positive, so can you get a minus pi by 2? Some as minus pi by 2? No, we can't get. Okay, if one is minus pi by 2, so definitely other should be 0. Okay, we can't get minus pi by 2 if one is negative and one is positive. We can check from here. Okay, so definitely this tan inverse x and tan inverse y should be negative here. Okay, and if tan inverse x and tan inverse y both are negative, then definitely x and y should be negative here. We can say. So from here we can say from this inequality, x and y should be negative, less than 0. Correct. Okay. Now, while solving this inequality here, see this tan inverse x plus tan inverse y is greater than minus pi is obvious. Yes, obviously no, because if you add these two, just now I've told you that minus pi by 2 to plus pi by 2, this is also from minus pi by 2 to plus pi by 2. After adding the lower limit is definitely minus pi. Okay, so this is obvious. Okay, this part is obvious, but this tan inverse x plus tan inverse y is not obvious. This sorry, tan inverse x plus tan inverse y less than minus pi by 2 is limiting here. Okay, so we have here limiting inequality. Okay, so we have to solve this tan inverse x plus tan inverse y less than minus pi by 2 only, because this is only the limiting inequality here. Okay, so tan inverse x plus tan inverse y less than minus pi by 2. Okay, now let's take this tan inverse y this side here. So we'll get tan inverse x, okay, is less than minus pi by 2 minus of tan inverse y. Correct, no? Okay, now from here also we can say this tan bus x less than minus pi by 2 and plus, can we take this minus here? Yes, we can write now because tan bus function is odd function. We know tan bus minus y. Then again, this is tan bus x less than minus pi by 2. Just take minus common, okay? So we'll get pi by 2 minus of tan bus minus y. Okay, and this is tan bus x less than pi by 2 minus tan bus is what? Cot inverse. Okay, so this is minus of cot inverse minus y. Okay, you know, if y is negative, so definitely this minus y will be positive. So cot inverse minus y can be written as tan inverse of minus 1 by y, you know, like this. See, tan inverse x less than minus of tan inverse minus 1 by y. Then also further we can write here tan inverse x less than tan inverse 1 by y. Okay, from this. Okay, if you insert this minus here, you'll get this one. You know, tan inverse function is increasing function. Okay, so if you'll remove this, if you'll compare this x and 1 by y, so you can compare this using same inequality here, no? Clear? Because tan inverse function is increasing function. Okay, also we know y is negative. Okay, see from here, y is negative. Okay, so if we'll multiply by y on both sides, what we'll get here? We'll get x into y is greater than 1 because inequality will change. Okay, so from this inequality, we got xy greater than 1. Okay, so we can write further this one like this. That let's see the branch ones. What was the branch? The branch was a plus b plus pi. Okay, so we can say tan inverse x plus tan inverse y plus pi. Okay, equals this a plus b. Sorry. This is a plus b plus pi. This is for minus pi to minus pi by 2. No, a plus b from minus pi to plus minus pi by 2. That is for just a minute. And you know, this is the branch of this tan inverse of x plus y by 1 minus xy. No, so you can write here further equal to tan inverse x plus y by 1 minus xy, and this is for which xy? X comma x into y greater than 1. Okay, x into y greater than 1. Then and also x comma y less than 0. Okay, that we have supposed earlier, not supposed, we have found earlier. Okay, so from this we got one formula here, that is tan inverse x plus tan inverse y equal to minus pi plus, just take this pi this side, so tan inverse x plus y by 1 minus of xy. Okay, and this is for x into y greater than 1 and x comma y negative. Okay, so we have proved one branch. Okay, that is one branch from that formula. Okay, let me cover this branch here. Okay, this branch we have proved here. Okay, so this was the first branch. Let's see once the original formula here. See, this was the original formula. You can see from here. Minus pi plus tan inverse of x plus y by 1 minus xy for xy greater than 1 and xy less than 0. This we have proved here. Correct? Okay, now next we have to see here this one. Okay, let me take this one minus pi by 2. Sorry, first of all, just take this one. Okay, pi by 2 to pi. Then we'll discuss about this one. Okay, so a plus b between pi by 2 to pi. Now a plus b between pi by 2 to pi. Okay, just further replace this a plus b. So pi by 2 here, tan bus x plus tan bus y here, pi. Now see here, this interval is positive. Okay, and the lowest value is here pi by 2. We know this tan bus x is between minus pi by 2 to plus pi by 2. Also this tan bus y between minus pi by 2 to plus pi by 2. Okay, for lower limit this pi by 2. Okay, see, you know, this if you add this two inequalities, so definitely we'll get pi, in upper limit here. Okay, so this is obvious. Obviously this tan bus x plus tan bus y is less than pi. Okay, but see, this is more than pi by 2. See, this is confirmed that if this sum is more than pi by 2, then this should be positive. Okay, tan bus x and tan bus y both should be positive. Okay, then only we can say this value will be more than pi by 2. Correct? Okay, because for pi by 2, one should be definitely pi by 2, other should be 0 there. Okay, so clearly from here we can say x comma y is positive. Done. Also, one thing is clear that this tan bus x plus tan bus y less than pi is obvious inequality. Okay, but this tan bus x plus tan bus y more than pi by 2 is limiting inequality. Okay, so we have to solve only this this inequality. Okay, that is tan bus x plus tan bus y greater than pi by 2. So let's write here tan bus x plus tan bus y greater than pi by 2. So do again the same thing here. Just take this y this side, tan bus y this side. So tan bus x greater than pi by 2 minus of tan bus y, and clearly we can write here tan inverse x greater than cot inverse y. Okay, so clearly this is tan inverse x greater than tan inverse of 1 by 5. Okay, and we know this tan inverse x function is increasing function, so x greater than 1 by 5. Clear? Okay, and from here, if you know x and y both are positive, so x, if you multiply both sides by y, so x into y greater than 1 will get again. Okay, just rewrite this formula again here. Then see, just take the branch here. Which branch we have? See, we are solving this branch, this one. Okay, so a plus b minus pi. No, this branch is a plus b minus pi. Let's write down. So tan bus x plus tan bus y minus pi equal to tan bus of x plus pi by 1 minus of xy, x plus y by 1 minus of xy. Okay, and this is for which inequality here, which interval? This is for x into y greater than 1 and x comma y both positive. Done. Okay, now from this we can also write tan bus x plus tan bus y equal to pi plus tan bus x plus y by 1 minus xy. Okay, and this is for xy greater than 1 and x comma y greater than 0. Okay, let me round this formula, cover this formula like this. Okay. So again, we have solved this branch. Okay, we have proved this branch. In fact, okay. See, we can see from here. See, okay, the original formula is here. Okay, this one. We have proved this branch. Okay. Now, one more branch we have to prove here. Let me take that that one. Okay, for this from see from here. This inequality. Okay, this is left now. This one minus pi by 2 to plus pi by 2. Okay, this you have to prove. This you have to solve the inequality again. So now minus pi by 2 to a plus b between pi by 2. Okay, so minus pi by 2 here tan bus x plus tan bus y. Okay, here pi by 2. Now for this inequality, can you guess about tan bus x and tan bus y? What can you say? Both positive, both negative? Yes, it can be both positive. It can be both negative also, or it can be of opposite sign also. Clear now? Okay, so here x and y, just write down here x and y can be both positive, both negative, or both having different sign. Okay, now to prove this inequality, let's take first this both positive. Okay, taking both positive. Okay, so clearly this tan inverse x plus tan inverse y will be greater than 0, okay, and less than pi by 2, no, because we have taken both as positive. Okay, now if tan inverse x, tan inverse y both positive, so definitely this is greater than 0. So this is obvious inequality here, greater than 0. Okay, and this is limiting, no, tan inverse x plus tan inverse y can go up to pi also. Okay, so this is limiting inequality. So we have here, we have to solve the inequality, this one, tan inverse x plus tan inverse y less than pi by 2. Okay, for this, what we'll do, we'll again send this tan inverse y this side. So pi by 2 minus of tan inverse y. Okay, and this is tan inverse x less than, this is what, cot inverse of 1 by y. Okay, we have sorry, tan inverse of 1 by y. This is cot inverse y. So we can directly write here tan inverse of 1 by y. We have done earlier this one. Okay, so from here also we can write x less than 1 by y. Okay, and we have x and y both positive, so definitely x into y less than 1. Okay, so we got here x into y less than 1. Just take both negative and check. Taking both negative, okay, that is tan inverse x plus tan inverse y between minus pi by 2 to 0. Okay, clearly if both are negative, then this inequality is obvious, that is tan inverse x plus tan inverse y less than 0. Okay, but tan inverse x plus tan inverse y greater than minus pi by 2 is limiting, because tan inverse x plus tan inverse y can goes up to minus pi also. Okay, so we'll solve only this one, tan inverse x plus tan bus y greater than minus pi by 2. Okay, both negative means definitely x, y both are less than 0. Okay, now from here tan bus x equal to, sorry, not equal to, greater than minus pi by 2 minus of tan bus y. Okay, and that can be also written as tan bus x greater than, here see minus pi by 2, just write down plus here and here tan bus of minus y. Okay, so tan bus x greater than, let's take minus pi by 2 as common here, sorry, minus as common here, so pi by 2 minus of tan bus minus y, these things we have done earlier. So here tan inverse x greater than minus of, see this is actually cot inverse of minus y, that is again tan inverse of minus 1 by y, because minus y is positive. Now just send this minus here, so we can write x greater than 1 by y. Then, and we know x and y both are negative, so if you multiply by y on both sides, we'll get x into y less than 1. Okay, so again we got here x into y less than 1. Then also if xy is negative, less than 0, so definitely x into y will be less than 1 only, no? Okay, now see next one, if you'll take both are having different sign. Okay, we are left with one inequality, both are having different sign. Okay, so I suggest you to do this, solve this inequality, that is both having different sign. Okay, we'll get same thing here. Okay, again x into y less than 1. Okay, clearly no, if x and y are having different sign, then x into y less than 1, that is obvious, no? Okay, because see, we can also say if both are having different signs, then x into y is less than 1 is obvious. Okay, because it will be negative, no? If both x and y are having different sign, then definitely x into y is negative. Okay, so definitely less than 1. Okay, so this is obvious. Okay, so what we got here then? We got, let's see the branch once again. See this one, a plus b, no? Simply a plus b. So we can write here like this. This is a plus b. Okay, or write down simply tan bus x plus tan bus y. Tan bus x plus tan bus y equal to tan bus of x plus y by 1 minus xy, and this is for xy less than 1. Okay, that we have proved from here. Okay, so we have this branch also. Okay, so definitely if you combine this all three branch, so we can say tan bus x plus tan bus y is definitely this one. Okay, tan bus x plus y by 1 minus xy for xy less than 1, minus pi plus tan bus of x plus y by 1 minus xy for xy greater than 1, and x comma y less than 0, pi plus tan bus of x plus y by 1 minus xy for xy greater than 1, xy greater than 1 and xy, x into x and y both are positive. Okay, so clearly we have proved this formula. Okay, students, I advise to remember this formula, okay, for your examination. But no need to remember this proof. Just for your knowledge, you can learn this proof also, okay, from this video. Thank you.